Hello dear students, good evening. This is Khadar handling JEE and NEET classes of V4U. Today we are going to continue our lecture in solid state. Now in this session we are going to discuss with respect to here coordination number. Coordination number. Okay, now let us start here. What is meant by here coordination number? Coordination number. Okay, now what is the definition of this coordination number? Okay, it is here defined as the number of nearest neighboring atoms. Number of nearest neighboring atoms present in a crystal, present in a yes crystal or crystalline lattice, that is called as here coordination number. What I dear students, the number of nearest neighboring atoms that present, or we can write here present, or we can write here touch to other atoms, touch to another atoms, that is known as here coordination number. Generally first of all we are going to take here now with respect to here types of the coordination number. First of all I can consider here 1D, one dimensional lattice or one dimensional, we can consider here one dimensional, one dimensional packing we can consider here, one dimensional packing can consider here. Now this one in case of here one dimensional 1D packing, how the atoms arrangement in a crystalline lattice, just you have check it dear students here. Now in one dimensional how the atoms are there, just have check it here. This is the way, only one layer, only one layer, just have check it here. Now sir, what is the coordination number of this particular packing sir, of particular crystalline lattice? Just we have to consider here. For example, if I consider any atom here, if I consider this one or this one or this one, this one, anything you can consider. Now for example I am considering this particular atom, this particular atom. This atom is touch with how many neighboring atoms dear students, just have check it here. This atom is touch with this atom and as well as here this. Am I correct or not? That's why the coordination number for this one dimensional, that means here all the atoms we have to arrange in the linear form, that we have to identify after you arranged all the atoms in a particular linear form, how many atoms which attached to this atom, or this atom or this atom or this one, we can consider anything. That's why it is called as here coordination number, number of nearest neighboring atoms that touch to other atoms in a particular crystalline lattice, that is called as its coordination number. Now in this case the coordination number is equal to how many dear students here, check it, this this atom attached with this atom and this atom, so its coordination number is equal to dear students 2. Am I correct? Next one, in that one dimensional got over, next one comes under here two dimensional packing. What is dear students? Two dimensional packing. In the two dimensional packing dear students, generally we are observing the two types of the packing. What is dear students? Two types of packing we are observing. The first one it is called as here two dimensional, the square packing. What is here? Two dimensional square packing. Next one same here two dimensional hexagonal structure we are considering. Hexagonal structure we can consider here packing. In these two conditions, in these two types of packing we are going to observe in the two dimensional. Here just have check it, all the atoms arranged in the single layer, that's why it is called as one dimensional. Next one what I am taking here, two dimensional. That means here in that particular layer I can arrange one more atoms. That is known as here two dimensional packing. Okay, now in the two-dimensional packing, we are going to observe two types of the close packings here. Square packing or square close packing, and next one you can consider here hexagonal close packing we are going to observe. Let me start with here first one here in this one. Two-dimensional square packing. Two-dimensional, dear students, square packing. Just have check it. Okay, now in this particular one-dimensional, what I consider, one layer of the atoms I consider. Just check it here. Okay, correct or not? This one, exactly the same. You are taking other layer. This is the two-dimensional only, dear students. I am not considering three-dimensional. Three-dimensional means that is the different. Okay, next one more. Okay, atoms I am arranging is the same. In such a manner, all the atoms should touch with first layer. Next one I am taking here another layer. Just have a check it, dear students. No need to get any confusion here. Am I correct? Okay. Now just if you check it here, this is called as dear one-dimensional layer. This is, dear students, one-dimensional. Okay, what I am taking, just if you observe in the sweet shops, they will be arranging all the different types of laddus in a different manners. Okay, in one layer is there, second layer, third layer, fourth layer, like that we are arranging. Here we can easily observe this is the two-dimensional. Two-dimensional, all the atoms, all the atoms I arranged in a two-dimensional manner. Just you have to consider, if you take it any one of the atoms in this particular here, this is called as, dear students, it will come two-dimensional one. If we consider any atom, this atom will be touched with how many neighboring, nearest neighboring atoms. Just I can consider here, for example, if I consider this atom, just check it here. Okay, I am considering this atom. This atom is touched with this atom 2, 3 and 4. Am I correct or not? Okay, by seeing itself we can easily understand its coordination number is equal to what, dear students? Okay, easily can say this is the 4. Coordination number, dear students, 4. Okay, now you mentioned sir here square packing. Okay, just we can consider square shape or not, dear students. Okay, now such type of packings is known as here two-dimensional square packing. Two-dimensional, dear students, square packing. The number of nearest neighboring atoms, the number of nearest, check, this atom is touched with here also touched, here also touched, here also touched. So its coordination number, now how it will come here, coordination number is equal to 4. Coordination number is equal to, dear students, 4. You can easily identify without having any confusion itself. Am I correct? Next one, in that same, I am taking here two-dimensional square packing over. Next one, I am considering here, two-dimensional, hexagonal packing. What is, dear students? Two-dimensional hexagonal packing. Okay, now hexagonal close packing also we can consider. Just you consider here, now how like I am taking the atoms here. Just you have to listen without having any confusion, we can take it here. Okay, check it. This is the atoms I arranged here. Am I correct? Next one, here also atoms arranging. Am I correct or not, dear students? Atoms are arranging in such a manner. Next one, what you have to do it, in between these two atoms, you have to take one atom here. Am I correct? Here also I am considering one atom in between these two atoms, one atom in between these two, I am counting. Am I correct? This is the one layer, second layer. Next one I am considering in between, the same. This is I can consider this is one, all the atoms here. Then after second layer, how you have to consider? In between these two atoms you have to consider without having any confusion. Okay, next one what I am taking, the same, in between atoms I am considering, in between the same, fourth one, like this itself. Fourth one, dear students, like this. As we discussed in the first layer, the third layer will be shown. Next one, I am taking here fourth one, 1, 2 in between only you have to consider in between. Am I correct? Now if you consider, okay, any one of the atoms, that atom is touched with how many nearest neighboring atoms? How many nearest neighboring atoms? That is, it's called as its coordination number. Okay, now let me take one atom here. That atom is touched with how many atoms? Okay, now let me consider this atom, dear students. Am I correct? This, okay, I am considering this atom. Now this atom is touched with how many neighboring atoms? Check it here. 1. Am I correct? Here 2. Here 3. Here 4. Here 5. Here 6. Am I correct or not, dear students? Okay. Now in that, now what I am considering here, just hexagonal. Hexagonal, just you have to take it here. Just to add this one. Hexagonal shape will come or not, just check it here. Am I correct or not? This is the hexagonal, check it here. 1, 2, 3, 4, 5, 6. Okay, now this atom is okay touched with how many? Okay, number of nearest neighboring atoms, dear students. 6 are not here. 1, 2, 3, 4, 5, 6. So its coordination number, how much will come here? 6 are not, dear students. Coordination number, dear student, 6. This is the very important point. Okay, in okay, this is okay. What is, dear students, with respect to coordination number? One dimensional completed. Next one, okay, 2 dimensional. In the 2 dimensional, we are having the okay 2D square packing and as well as here 2D hexagonal packing. Am I correct? Next one, very important. That is called as okay. That is third one. It is called as, dear students, 3-dimensional close packing. What is, dear students? 3-dimensional okay close packing. Close packing. Okay. In the 3-dimensional close packing, generally we are having 3 types. How many, dear students? Generally in 3-dimensional close packing we are having how many? Okay, types, dear student, 3. Now first of all I can consider this is okay. Now first of all what I am taking here, 3-dimensional. Okay, 3-dimensional I am considering here. Okay, in that 3-dimensional, okay, what are the types will come, just you have to check it here. 3-dimensional, you know, AA. This is the type. This is the first type, dear students. This is the type 1. Okay, next one comes under AB. Next one AB. This is called as, dear students, okay, second type close packing. In what? Okay, here dimensional, 3-dimensional we have to consider, dear students. 3-dimensional we are mentioning because okay, y-axis we can't able, because the x-axis here also, y-axis here. Okay, where is the z-axis here? Z-axis which is perpendicular to each other. These 3 axes which comes under perpendicular to each other, that's why we can't able to see. Okay, this is the z-axis. Am I correct or not? But I am trying to draw okay, 3-dimensional structures here, just without having confusion, just you have to understand here. This is AA type close packing okay system. Next one, second one called as AB type. Next one, third one, it is comes under, dear students, ABC and ABC close packing. Am I correct or not? Okay, now first of all in that okay AA what is come here? First of all I am considering okay, in that what I am taking here, first one AA type here, 3D square packing we are observing. In that what will come, dear students? 3D square packing. In the bracket I mentioned here AA. Okay, now first of all if you want to understand or if you want to draw the 3-dimensional close packing or 3-dimensional structure, first of all you need to okay draw 2-dimensional first, then after you have to insert the okay, third layer over the okay 2D okay layers, over the 2D layers. Now first of all the same thing I am considering which we discussed here, 2D square packing, here 3D square packing I am considering. Am I correct? Here 2D, here 3D. Okay, that means everything is same as we discussed in this, everything we are writing, but how we are mentioning okay third layer, sir, we can see. Okay, now I am taking first of all, okay, 2D square packing, 2D layers I am considering. Am I correct? Next one. Am I correct, dear students? This is called as okay, two-dimensional layers. Okay, in that generally, first of all, this is called as two-dimensional. Here generally everything it is comes under, dear students, 2D. Am I correct? Next one, in that 2D, what you have to do it here. Okay, square plane. Okay, we can easily identify. Okay, if you consider any atom here, okay, I can consider this atom. Just check it here, students. If I consider this atom, what will happen? This atom, okay, this atom is touched with how many nearest neighboring atoms here? This one, and this one. Okay, we can easily say this is the coordination number 4. Sir, then what is the point of difference between the 2D square packing versus 3D square packing? Am I correct or not? Okay, now for that what I am taking here? The third layer I am taking. What is, dear student? What I take it here? AA, that indicates here, okay, 2D, third letter A. That is indicates here, okay, third layer we are going to introduce on, okay, 2D layer packing or 2D layer structure here. Okay, how we are inserting, sir? Just I am considering here, this is the atom. This is the third atom, third layer. This is, dear student, this is the third layer. Third one is all. Because, okay, now if I arrange one more layer on this particular atom, we can't able to see. We can't able to see. That's why we are getting confusion, because it is comes under three-dimensional one. Okay, then what I am taking here, if I take it, this, imagine this all called as laddus. If I put one more, okay, laddus layer on this particular one, then what I have to do it here? Okay, this, okay, the upper, the laddu part will be appearing to us, and the okay, next one, the laddu which is down, okay, that is behind that one, we can't able to see. That's why I am mentioning it is small one which indicates here. This is called as 3D layers. What is, dear student? This is comes under 3D layer. Now here also I am checking, take it here. This is 3D. This is also 3D here. Third layer. Here also third layer. Okay. Now you understood here. 1D layer in the packing, only one layer we are considering. The 2D is what we are considering here. 2 layers we are considering. Okay. That's coordination number is equal to 4. Here coordination number is equal to 2. But I am considering 3D dimensional here. Check it here also one. Okay, I am arranging third layer. Check it. Third layer. Am I correct or not? Now this, okay, nearest neighbor, okay, nearest, okay, now what is the neighboring atom? That means if you consider this atom 1, 2, 3, 4. Am I correct? Sir, what about this atom? This, okay, if you put one more laddu on this particular atom here, on particular laddu, what will happen? The upper part will, okay, appearing to us. Next one, the, okay, below part also is there, no? That will be behind that one. That means here, this atom is touched with this one, 1, 2, 3, 4, 4 completed. Next one, this atom is touched with the down part, and as well as one more part will be appearing towards us. So obviously we can say this coordination number generally, how do you see, dear students, here? Coordination number is equal to, dear students, 6. What is, dear student? Coordination number is equal to 6. That's why this small which indicates, dear student, 3D layer. 3D layer. Okay, if I put same, okay, one more atom here on this particular layer, you can't able to, okay, differentiate between the 2D versus 3D. That's why I mentioned here small one. Am I correct or not? I mentioned small. That's why, for example, if you consider this is x-axis, this is y-axis, z-axis will be like this. Z-axis will be like this. You can't able to, okay, identify. We can't able to see. That's why I arranged one small layer, okay, small laddus, okay, small one which is completely I have considered. This is comes under, dear student, third layer. It's obviously coordination number, how much, dear students? 6. Okay, this is comes under, dear student, AA type, okay, packing. In that one 3D square packing we are observing. 3D square packing. Just you have to check it. This is called as square only we are observing, no? This is a square we are observing. But this atom is touched with, okay, this is towards us, towards the viewer, and as well as one more part which is behind that one. That's why the total number of nearest node, okay, neighboring atoms is equal to, dear students, 6. This is very important, don't get confused. Next one we can move to ABAB type and ABC type. We can do, students. This is also very important, and this one we can easily identify how many type of okay, this A indicates what, this B indicates what, this C indicates what. If you understand, then we have to, okay, understand what is the how many atoms which are touched this one. Okay, students, please note down. Okay, dear students, let us continue, okay, our, okay, 3-dimensional close packing. First one completed here, 3D square packing, AAAAA type, okay, close packing. In that, okay, what we discussed, dear students, total, okay, number of, okay, this is comes under first one, this is 1D layer, second, okay, layer, okay, here like that we arrange. This is comes under only 2D layer packing. Okay, next 2D layers arranged in all the, okay, atoms in a crystalline lattice. Okay, next one, how we are considering a third atom. Okay, we have to, because it is comes under 3-dimensional, dear students, that's why the, okay, third layer I put it in between the here atoms here. So what will happen here, coordination number is equal to 6. Next one, let us move on to the, okay, next one, that is called as okay, that is okay, called as here ABABAB type, ABABAB type packing. Am I correct or not? ABABAB type packing. Generally here, what type of packing we are going to observe, dear students? What type of packing we are going to observe? Now, generally what we are, okay, we can consider here 3-dimensional, okay, hexagonal, 3-dimensional hexagonal close packing we are observing. Close packing we are observing. Okay, simply we can represent here HCP. Am I correct or not, dear student? HCP, 3-dimensional, okay, hexagonal close packing. Am I correct or not? Okay, sir, how we are going to observe in this one? Hexagonal close packing. Hexagonal close packing, how we are observing? This one here, the atom A which is indicates here, okay, 2-dimensional one, 2-dimensional one. In that next one, this atom B which is indicates, dear students, here 3-dimensional one, 3-dimensional one. Okay, in that 2-dimensional, if you take it here, what type of, okay, taking here 2-dimensional which is comes under, dear students, hexagonal one. Next one, 3-dimensional, what you are considering here, that is we are observing, going to observe tetrahedral voids. Tetrahedral voids. What is tetrahedral voids and what is octahedral voids, we are going to discuss now. Okay, now if you consider here 3-dimensional hexagonal close packing, okay, close packing, if you consider here how to hexagonal, simply without having any confusion we have to remember. Okay, now first of all I am going to draw here, okay, 2-dimensional, how like I am considering, check it, dear students. Okay, now I am arranging to make it to understand, just I am taking, okay, some gap between the two atoms, gap between the, okay, two atoms here. Okay, this is an atom I am considering, taking some gap between. Generally we have to, okay, we have to keep it, okay, touch with this one atom to another atom only. To make it to understand only, just I am taking here like this. Okay, this is third atom, fourth atom, we can consider here fifth atom. Okay, now I can consider like this itself, no problem. Okay, next one, in between these two, what I am taking here, okay, now take like this one atom, make it here, make it. Am I correct? Next one, we are taking here same, in between these two, we are taking one atom here also one atom. Next one, come, same, first layer and also third layer will be same. Am I correct? Next one here common, this is and this one. Am I correct? Now how like I am taking here, okay, how we are observing here hexagonal, okay, dimensional, okay, and as well as, okay, atom B if you consider here, okay, 3-dimensional tetrahedral voids. Tetrahedral voids, how like we are observing, just we have to consider these two, okay, 1 2 3 These 3 atoms are there or not? These 3 atoms what I am taking, just check it here. Okay, now these 3 atoms I am considering like this. Okay, now immediately I am putting what is, dear students, check it. Okay, next one, take it here. Sir, why you are drawing, sir, like that? Just let me finish in this one, then I will explain. Just check it here. Am I correct or not? Okay, next one, if you consider here atom, okay, what type of atoms you are considering next? Okay, these 2 atoms if you consider here, 1, 2, 3, okay, or else you can consider this atom and as well as this atom. Check it, dear students. Okay, 1, 2, 3. 1, 2, 3. This is also comes under this. I am going to mark it here. Okay, next one, 1, 2, 3. Okay, or else 1, 2, 3 I am considering here. Okay, if you take it like this here, if you take 1, 2, 3, 4, 5, 6. Okay, now just if you consider like this here, take it, dear students. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3. Okay, 1, 2, 3, 4, 5. This is comes under 6. This also comes under. Next one, the common here. Here also 1. Here also 1. Okay, now what you are observing? Am I correct or not, dear students? Just have a check it. Okay, now these 2 once check it here. 1, 2, 3, 4. First of all, how like we are observing tetrahedral voids. If we consider here like this, here one atom is there, another atom is there, next one, third atom. Okay, now these 3 atoms, just I am taking one more layer on this one. Okay, now how many atoms are there, students, here? 1, 2, 3, 4. Tetrahedral shape already we know. This is geometry, okay, of the tetrahedral. Am I correct or not? Just if you consider like this. Okay, now such type of voids is called as here tetrahedral voids. Such type of voids is called as, dear student, okay, tetrahedral voids. Am I correct or not? Okay, now if we consider here, just check it. Okay, these 3 atoms, shall we consider this is tetrahedral void? Tetrahedral void. Next one here also 1, 2, 3. Here I am considering tetrahedral voids or not. Next one here also 1, 2, 3. Tetrahedral voids or not? Tetrahedral voids. Next one, if we consider here 1, 2, 3, 4. This is comes under, dear students, tetrahedral voids. Next one here 1, 2, 3. Tetrahedral voids or not? Tetrahedral voids we are observing. Here also come, dear students, 1, 2, 3. Tetrahedral voids we are observing. Here also 1, 2, 3. Tetrahedral voids. Sir, are you observing? Okay, dear students, are you observing any type of here octahedral? Okay, voids here, octahedral voids. Generally, octahedral generally how we have to represent, dear students? This is atom A. Okay, I am considering this one. Am I correct or not? Okay, now just if you consider these 2 atoms, if you join here, 1, 2, here, here. Am I correct or not? Okay, now we are observing, check it here, 1, 2, 3, 4, 5, 6. Here we are observing what type of voids, dear students? Octahedral voids we are observing. This is called as, generally we are discussing in ABC type close packing. Am I correct or not? Now here are we observing any type of here? Just you observe 1, 2, 3, 4, 5. Okay, 3 here also. What is, dear students? 3. Then we can observe here octahedral voids or not? Octahedral voids we are observing. Am I correct or not? Here also we can check it here 1, 2, 3, 4, 5, 6. We can observe here also. Okay, octahedral voids. Octahedral voids. Okay, this is the way we have to study. Okay, AB type close packing, dear students. Okay, next one. Okay, ABC here is still there. Simple. Okay, in that one, AB, what you are going to observe here comes under ABC. Here, ABC and ABC type close packing if you observe here. In that, what you are doing, going to observe, dear students, here. This is okay, A, B, C. We are observing this A, which is indicates here 2D hexagonal, B, which is indicates, dear students, okay, 3D tetrahedral voids, the C, which indicates here 3D, what we are observing, okay, octahedral voids. A, which indicates, dear students, 2-dimensional hexagonal, 2-dimensional hexagonal. That B layer, which indicates here 3-dimensional, okay, tetrahedral voids. Next one, which is C, it indicates here 3-dimensional here, okay, octahedral voids. Octahedral voids. Am I correct? Simply just now I have shown here how we have to represent here atom A, this one and this one. Am I correct? Now how we are taking, dear students, this is and this one and this one. Am I correct? Total number of atoms, how many, dear students? 6 or not? Okay. Now we can consider this is we already observed in that ABAB type itself. We observe what is, dear student, octahedral voids we observed or not? 1, 2, 3, okay, 4, 5, 6. Okay, here octahedral voids we observe or not? Octahedral voids. Okay, this also you can consider this is octahedral voids. Okay, dear students, this is comes under 3-dimensional close packing. 1-dimensional, okay, what you are doing, students, the number of neighboring atoms. Okay, generally coordination number we have to represent the number of nearest neighboring atoms which touch to, okay, another atom in a particular crystalline lattice. Okay, 1-dimensional we observe, 2-dimensional we observe. In the 2-dimensional we are having the two types. One is comes the 2-dimensional square packing, next one 2-dimensional hexagonal. Okay, next one 3-dimensional we observe 3 types, AAA, okay, next one AB type, next one ABC. Okay, this is generally we have to represent, okay, coordination number in different types of the close packing, dear students. Okay, please note down, dear students.